Okay, question 9. Shot put is an athletic field event in which competitors throw a heavy spherical ball, a shot as far as they can. The size of a shot for men is different to that of women. The diameter of the shot for men is 1.5 times larger than the diameter for women. And the ratio of surface area of women's shot to the total area of men's shot is. So the question here, surface area of women's to men. So we need to think, all right, we're going to need area ratio, and we want to write it women's to men. So up here highlighted in the purple, they gave us a length. They said that if you had the women's and you times it by 1.25, you get the men's shot put. So really we got given a ratio. This is like the scale factor, or the length is the scale factor, or the length ratio. And so, but it's in a decimal. So because you've got 1.25, that's a decimal. You want to make it into a fraction because our ratio is like a fraction. So what I'm going to do is I'm going to say it's like 125 over 100. So because this is the hundredths, I put it over 100. And then that simplifies down to 5 over 4. So really, this would be the men's and this would be the women's. So if I have the length ratio, if I wrote it in terms of women to men, I'd have 4 to 5. Now when we want to get the area, we square them, so I end up with 16 to 25. So there's that answer. Okay, so here you've got your pyramid, and it said the ratio of shaded volume to the unshaded. So really what you've got, you want the volume of that top bit versus the volume of this bottom part of the thing. Now these two parts here are not similar. So that's not what we can use. There is similar shapes here, but it's not those parts of it. So what we need to see is that we have a pyramid up the top here. So I'll just call that my little one. And then I have a larger pyramid with the whole thing. So, and I'll call that like my large one. Now when they write a height and 2 height, that's giving a length. And really what I can say is a length ratio. If I've got 1h here and then I've got 2h there. So the length ratio is 1 to 2. Now we're talking about volume. So if we want this bit, the volume of that bottom part, what it's going to equal, it would equal the volume of the large one minus the volume of the small one. Because if you cut that off, you'll end up with just the bottom bit. So if we go get the volume ratio up here of those two things, so remember we would cube it. So it'd be 1 cubed to 2 cubed. So it's 1 to 8. So when we talk about ratios, we can just sort of pretend like that's the actual volume. So if this one was 8, then the little one is 1. So then if that was the case, this bottom part would be 8 minus 1, which is 7. So when they ask me to do the volume of the pyramid to the shaded to the unshaded, well, this one here, the pyramid is, the blue one. So it had a volume of 1, and the bottom part has a volume of 7. So we say 1 to 7. That's the answer. Okay, so here in the question, they want the circumference of the smaller cone. So the circumference, remember the formula for circumference could be... Okay, the circumference of a circle is pi times d. So I'm using this formula because they're giving us the diameter in there. So they want the circumference of this little circle. So I need the diameter across here, that diameter. So what we do have though is similar figures. So I'm going to call this bottom cone is like the small one, and then the whole thing is like your larger figure there. All right, so then I have the larger cone here, and they've given me some dimensions. I've got 90 and I've got 30, so I can compare, and I also know that this is 48 across here, and this is the diameter that I need. So I can use corresponding, because they're similar, I can use corresponding ratios to do it. So I can say that so essentially what I can say is that 90 over 30 must equal 48 over d. So we're just double checking that these are coming from the same shape. So that's coming from the same shape, which it is, the big shape, and the ones on the bottom are both coming from the small one. So once you do that, we can solve and comma d, and we'll find out what the diameter is. And so we get the diameter to be 16, so that d is 16, so therefore the circumference would equal pi times d, which would be pi times 16, which equals we're going to round 50.3 millimeters. Okay, in this next question, a cafe sells 2 cupcakes with similar shape. So when they're telling you they're similar, so we can use all the ratios, corresponding ratios. So the large cupcake is 6 centimeters wide and the small one is 4. So really what they gave you there was a length ratio. Okay, so we saw the length ratio, and we've got pretty much, we're saying it's 6 to 4, but we could simplify that to be 3 to 2. Okay, and now the question says that the price of the cupcake is proportional to its volume. So what that means is it's scaled the same way as volume, the volume. So therefore we can use the volume ratio. Okay, so if we went to find the volume ratio, it would be the length 1 cubed, which ends up being 27 to 8. So then what we can do is you can use that. So you can say 27 over 8 must equal the same as if you divided the prices. So that's what we say when it's proportional. So the big cupcake was $5.40, and we want to know the smaller cupcake's price. So then you can just do solve, comma x, and we get x to be $1.60. And there's that answer. Okay, so this is question 9, and it was from an exam. So it always got a little bit of a challenge if it's the last questions, which 9 is. So let's have a look. A wedge of cheese in the shape of a triangular prism, and the base of the wedge of the cheese is 8 centimeters long as shown. A similar wedge of cheese is cut from the larger wedge of the cheese as shown in the diagram. The cut is made at a distance of d from the back edge of the large wedge. The volume of the small wedge is half the volume of the large wedge. Now find the value of d in centimeters. So what we have to do is we've got to find our similar figures, and we need to be a little bit careful in this one. So I'm going to say we have our we've got our original wedge of cheese here, and so I'll draw it up like that, and this would have its length. So if I redrew that, so we've got this big wedge of cheese along here, okay, and we know that's 8, and it's right angle, and that's the length. Then we've got our little smaller wedge, which they said is similar. But if you look here, so here's our thing, but it's still the same length. So if I drew it, what I'm seeing is that it's still, this bit is smaller, the face of it is smaller, but the length of it is the same. So when they say the volume, and if you think about if we think about volume, so volume is always the area of the face times the length, okay? So if our length here is the same, then the thing that's only changing is the area. So when they say the volume of the smaller wedge is half the volume of the larger edge, what they're really saying is the area of this face must be 2 times or bigger, or this one is bigger than this one's area of the face. So even though they said volume, because they're the same length, you're actually being given an area ratio for the similar things. So we want to compare just pretty much, we're comparing just the face, and we know that the area ratio is actually just 2 to 1, because that's the thing that changed. And if you look here, if I call this bit X from here to here, so that's X, we can see that 8 minus X equals D. That's how we're going to find it. So we need to find D. So if you think about it, we've got this area and we've got a length 8 and we've got the thing X. So these two things here, the 8 and the X, that's a length. So I need to go back to the length ratio. So the length ratio is when you do the square root, you square the area. So if I square root, it's square root 2 over square root 1. So once we've got it like that, we can just compare it, and you can still leave it in the square root. It won't make any difference. So we pop that in. Square root 2 over square root 1 must equal the 8 over the X. Okay, so we say 8 over X, and we can just pop in solve, comma, X, and we end up with X is 5.7. So therefore 8 minus X equals D. So 8 minus 5.7 equals 2.3. There's our answer. Okay, so this one was taken from last year's exam. Kalita has designed a logo for her business. The logo contains 2 equilateral triangles. The side length of the triangle is 4.8. Write a calculation to show that the area of one of these triangles is nearest centimetre is 10 centimetres squared. So I would say with this one, we can just use Heron's formula, and we haven't done that yet. So I'm sure you've done it last year, but you'd show Heron's formula. We'll do that later, but you just show that it's 10 centimetres squared. All right. In the next bit, it says in the logo, 2 triangles overlap as shown, and part of the logo is shaded and part of the logo is not. What is the area of the entire logo? So if you look, what we've got is this original triangle up here, and they've got 2 of them, and they overlap like that. Okay, so it's not going to simply be 2 times 10 squares, because there's a bit of there's overlapping. But if you look here, you can actually divide the triangle, the main one, up into little triangles. So what you can see is that it ends up, if I did like that, you end up with the original triangle having these little triangles. So within one of those original triangles, you can see we have we've got 1, 2, 3, 4 equilateral little mini triangles. So if I was finding the area of one of these, well, because there's 4 in the whole big blue one, I could say 10 divided by 4 will equal the area of one of those little ones. So if you look at that, therefore you could then just count. You've got 1, 2, 3, 4, 5, 6 of them. So if I said, all right, to find the area, I could say 10 over 4, that's one of them, but I have 6 of them. And if you do that, you end up getting 15 centimeters squared. So there's your answer. Now, when it says what's the ratio of shaded region to non-shaded, we can use those little triangles again, because the shaded has two of the little triangles compared to the unshaded, which has 4 of the unshaded. So we can simplify 2 to 4 to be 1 to 2. So there's our answer there. It says now the logo is enlarged and printed on boxes for shipping. The enlarged logo and the original logo are similar in shape, so they're told us similar. The area of the large logo is 4 times the area of the original. So they just gave me an area ratio there. So if I just wrote that down, area ratio, we would say 1 to 4. This was the original, this is the new enlarged one. And they're saying, because they're similar, that's why. Now, they said, what is the height of the enlarged logo? So we actually know from the beginning what the height of this one is, because one of those triangles is 4.8. And obviously, we're looking for this height there. Now, height is a length, equals a length. So I need the length ratio. So if I find the length ratio, is I do the square root of the area one, which is 1 to 2. So really, the height is 2 times larger. So 4.8 times 2, or you can still do it with your fractions and the solve if you like. So we end up with the height 9.6 centimeters. So height equals 9.6 centimeters. Okay, a string of 7 flags consisting of equilateral triangles in 2 sizes. So once you've got equilaterals in 2 sizes, that is indicating that they're similar because they've got all the same angles. So, and they hang on an end of a racetrack as shown. The edge of the black flag is twice the edge of the white flag. So what they gave you there was actually, they're giving you a length ratio. So if you've got the black flag and then you've got the white, so if that was 2, that's 1. It's twice the length of it. So that is a length ratio they gave there. Okay, now it says for the string of 7 flags, the total area of black flags would be, and then you can see in the answers they're comparing it to the area of the white, so they're using a ratio sort of language there. So if we first will go and find what the area ratio, what is the black flag compared to the white, and remember we would square those numbers, so it's 4 to 1. So the black flag area, if the black flag had an area of 4, this is the black flag, and then the white flag would have an area of 1. But if you look up here, we've actually got 1, 2, 3, we have 4 black flags, so I would times that by 4, and we actually only have 3 white flags, so 3. So if we're comparing the whole total area of all these flags, we actually have 4 times 4 is 16, and 3 times 1, we have 16 to 3, that the flag, there's more black flags. So this is how we get that answer of 16 to 3 there. Now with this question, you could use similar figures, and what we did is we could use that the big cone, so they've sort of demonstrated, you have like the big cone and it's similar to the top little cone. okay? And obviously, if you were trying to find the bottom thing, if you do the volume of this guy minus the volume of this, because you'd be cutting off that top bit, that will give you the volume of the bottom. Okay, so you can use similar figures because they gave you a radius. So the radius is a length. The radius is a length, which means you can get the length ratio or the scale factor, which they did there. And then they cube it, and then you can see this is the volume of the big cone, and then they found the volume of the small cone there, and they're minusing it. So you could find it out that way. Actually, on your formula sheet, I had a formula that you can work out the volume of this type of shape, which is called a frustum of a cone, the bottom bit of the cone. And if you do that, you'll get the same answer. So remember, we have a reference book, so you can just use that. Might have saved you a lot of time and got a good answer.